Gummerum is a German technician in measurement technology. He has developed the methodology over the last 20 years and is very successful in using it for finding water. Gamma exploration is a special geophysical method that measures and analyzes the background radiation from the Earth. It shows subnormal activity when it passes through oil and water. This pattern allows us to detect water resources and to determine the best spots for exploration drillings. Gamma radiation is analyzed by sensitive scintillation detectors with specially dotted crystal sensors. Gamma rays are received, converted into light flashes, and amplified as electric impulses by a photomultiplier. We can also identify the occurrence of specific isotopes of chemical elements by differentiating the gamma energy levels. This spectrography can be useful for finding natural resources. Scintillation counters are a proven technology. They are commonly used in geophysical surveys for several decades. Most of them are employed for analyzing radioactive spots. On the other hand, using background radiation for surveys is not common knowledge. This is our USP. The approach was originally developed by Dr. Armin Bickel, a German scientist who worked for NASA until his retirement. Thereafter, he founded his own company. He used his proprietary scintillation counters to prospect for water, oil, diamonds and minerals with great success. It was Dr. Bickel who introduced Edgar to the secrets of his method when they met together in California 20 years ago. You can see on this original graph from Dr. Bickel's manual that there is subnormal activity over water bodies and abnormal activity over their edges. He uses the term primary water. This is a non-conventional source of water that can be accessed through deep fractured rock formations. This approach represents a new solution for arid countries since the availability of these deep water sources is not dependent on precipitation. The primary water theory was developed by Stefan Ries, a brilliant German engineer who relocated to the US in the 20s of the last century. He was extremely successful and located more than 800 wells all over the world. Today, transformative technologies uses parts of the knowledge of Dr. Armin Bickel and Stefan Ries for exploration for new water resources. Our market entry in Africa was in 2017. The pilot project took place on the island of Madagascar in the Indian Ocean. The sites to be surveyed were in the far south. This is a very dry area where the people in the villages and towns are desperate for sufficient resources of drinking water. Hence our approach for looking for new water sources at places where the people need it most. However, before we could travel to Madagascar, we had to do some homework. We had to carefully look at the geological situation based on existing maps and scientific studies and analyze lineaments on maps, satellite imagery and digital elevation models respectively. We then pre-selected and prioritized specific areas. One of the most interesting geomorphic features is this small structure in the middle, which is about 200 meters across, with a small depression in the center, having dark soil at its surface and showing no vegetation. We were crisscrossing this area by foot in a grid of 10 meters and captured the background radiation along with the GPS coordinates. The results can be visualized in different ways. The profile line allows us to follow the path step by step and to see all details of the amplitude. Data errors would also be recognized easily. A very interesting pattern can be seen here. The areas with the lowest activities are in the middle and especially at the edges of the central depression. Other visualization tools include post maps, where you can directly differentiate between areas of low intensity, here being highlighted in blue, and areas of high intensity, highlighted in red. We made another survey along a straight line, which later became the survey line for passive seismic studies. Combining all data points together and rendering it in a heat map would allow us to directly identify the most interesting areas for further examination and to relate to the physical structure of the surface. The areas of low intensity can be spotted easily. They might be an indication for water resources. Generally, a project consists of 4 steps in 2 phases. The first phase takes place at home. The initial analysis on our desktop computers is based on existing maps and lineament studies and will reveal specific areas of interest. This is the most efficient way of narrowing down large areas to confined areas with the highest probability of finding water. Now the site operations start. The second step is the radiometric survey, which is the gamma exploration method in a narrow sense. Simply put, the goal of this step is to find anomalies in the background radiation. It should be mentioned that our survey can cover large areas and be carried out with a minimum of time requirements. Instead of going by foot, you can use a car, take the measurements from a helicopter, or mount the equipment on a drone. This, by the way, is the next development goal in our corporate R&D program. Using a drone will allow us to scan large areas and difficult terrain in a highly automated working environment and will further increase our efficiency. The purpose of the next step is getting an idea about the geologic structure beneath a survey point. The passive seismic method will be contributed by a cooperation partner who has developed a really powerful proprietary system. It will be used for determining the depth of water-bearing strata, vein, or aquifers. This analysis is labor-intensive and can only be carried out on small areas. Therefore, we need the gamma exploration method for finding the anomalies and hotspots and proceed to a detailed analysis with more radiometric surveys in a narrow grid, followed by passive seismic. At the very end, we will determine the best drilling points and demarcate them visually and save the GPS coordinates. Along a survey line, a passive seismic test will be run every 5 or 10 meters. This is an acoustic approach that will reveal certain structural elements in the depth and let us differentiate between solid and fractured rocks, as well as between consolidated and unconsolidated materials. You can see the results on the right. The yellow color of the right column indicates solid rocks, while the red and violet parts may indicate a fractured zone. According to the findings along the survey line, which represents the x-axis, we would expect having to drill until 85 meters or below in order to hit any water. The y-axis displays the depth. In order to prove that there really is water, you have to drill. There is no way around it. At the end, we really found water, at exactly 85.5 meters. We hit the water at the exact depth of our forecast. This is an impressive proof of concept that our geophysical survey method is really working in practical terms. We will help public water utilities in dry areas to get access to new water sources. Poor people in developing nations will become less dependent on fetching their water from dirty rivers. The ox carts can transport the water from wells nearby. And the children will be happy with having more water at their disposal.